insertion sort is also one similar technique, right, for sorting the elements in the arranging order. What is its logic? Okay, in bubble sort, we are comparing every two elements we are comparing. Again we are coming back, again we are repeating it like this, again you are coming back to 0, again you are comparing it, right? So you are trying to push the bubble to the end. Okay, this is a different kind of a technique. Insertion sort is little different kind of a technique, right? What happens here in this sorting technique is that, see, I will give a simple example. You are going to enter elements into the array. Suppose you are going to enter elements into the array. So while entering itself, you try to insert. See, I think the best example will be playing cards. I hope you all remember one small kind of, lot of things in cards, but one simple game was arranging numbers, no? In 1, 1, 1, if you make pairs, then 2, 2, 2, you get one thing, then 3, 3, 3, you make like this, right? So we have some certain games like this. In cards, you try to just put them everything in order. Okay, so what you generally do while playing those cards, you will try to take the already you will pick the first card. Okay, your goal is to arrange them in order. I think you are aware of this game of playing cards, right? You will get some 10 or some 11 or 13, 12 or 13 cards. In that, you will lift the first one. If you see the first card is 3, you will hold it in your left hand. Then this is card 1. Then you will take card 2. Then you will pick up the second card. When you take the second card, if you observe that the second card is A, for example, the second card is A, then what will you do? You will try to put this before this 3. So your hand, which was 3, now became A3. Okay, it became A3. Next, third time you took third card. It is 9, for example. If it is 9, you will put it here. On your left hand side, you are holding those two cards, A and 3 together. You will put 9 here, right? Then you will pick up the fourth card. When you take the fourth card, you will see there is some element, maybe queen, then you will try to put it here. Then fifth one, if you get 2, then what will you do? In this case, you will try to insert that here. You will try to insert that in this location, right? So what you are doing, as soon when you are picking up the cards while playing, you are trying to arrange them as soon as you are picking it. You are not taking everything in hand and then arranging. You are taking one by one from that deck of cards, or the 12, 13 cards which were given to you, which were shared to you. You will take one by one and you will arrange it so that it is very easy for you to play the game, to make this kind of matches, 2, 2, 2 or Q, Q, Q or A, whatever you say, right? That is the logic of insertion sort. While inserting the elements into the array itself, then and there we will try to sort the elements. Okay, from your left hand side, you are trying to put the elements into right hand side. You will do it then and there, like the playing card example. Okay, so let's see how it happens. Let's see a small example how this insertion sort works. Okay, it will begin from the 0th element only. 0 is there, fine, the value is 2.78. okay, what is the second element which has come? 7.42. where it has to be placed? It is greater than 2.78, so it has to be here only. It has to exit here only. Next came the third element, 0.56. when the third element I pick, the third card which I took on my right hand side, then I could see on my left hand side I have two elements, 2.78 and 7.42. What you have to do? You have to compare this with this element. Okay, whether it is large or small. If it is large, then you have to compare this with this element. If this is large, then you have to bring this to this location. Okay, like this. You will compare this two and swap. Again, you will compare next to 2 and swap. You are trying to swap it here. This way, when the new element came, it is already in sorted order. So that is the major advantage of insertion sort. In bubble sort, if you see, you are able to generate the sorted order only after the last iteration. Whereas in insertion sort, you are generating at every level. in each comparison, you are trying to generate a sorted order. At each interval, at each iteration, you are having always a sorted order with you. You are picking a new card, it is in sorted order. You are taking one more card, you are putting them in sorted order. So that at any point of time on your left hand side, you always have a sorted order of cards like this. Now the next element comes 1.12. What will happen when 1.12 comes? I have to compare this with 7.42, right? And I have to swap it. Again, this I have to compare with 2.78. Again, I have to swap it like this. Now, I'll again compare this with this, but not required. It can be there. Even if I compare, it's not required. Then the fourth element, 1.17. So, it will compare with this, then compare with this, then compare with this, and insert it like this. Okay. So, this way, it is again comparing, and it has come to its place. Then 0.32. So, it will compare with this 2.78, then it will compare with 1.17, compare with 1.12, and then compare with 0.56 and reach that location. Okay. So, as on one, we are increasing the value. We are going to next index. We are taking this value, comparing with this, with this, with this, and so on. If it is less, swap. If it is less, swap. If it is less, swap. Then and there, we are generating a sorted order of elements. Okay. Next, 6.21. So again, you will compare, not required now. So 4.42, you will make two comparisons. It is in sorted order. Like this 3.14, you will compare three comparisons and reach the location. So this is the way you are doing the insertion sort. It is used. If you want to remember it, simply remember as you are playing cards, picking up the cards on your left hand from the table. You are picking each card once and you are trying to insert into your left hand in sorted order. Okay. So this is the logic of insertion sort. So let's try to understand now how do we write the code. So what is required here? How many iterations do you think are required? How many for loops do you think are required for this? Can we do it with single for loop? How many for loops do we need for this? Any guess of the number of for loops? Right, because you have to maintain two indexes, one index to grow like this from 0 to n minus 1. That is your I index. Then your j index to always compare this back, again, right? Same way, but let's see the logic here, what we are trying to do. So that is I is 1 to n, or you can take any value, I equal 1 to n. See, key equal to a of I. That is very important step here. The key equal to a of I means a of here array is beginning from 1. It can be 0 also, right? So we have to begin from 1. Key equal to a of 1. It means in that array you have elements like this. You have 3, 5, 1. Let's take 13, and then 1, 7, 9, 9, 3. Yes. So I am taking this as my key. So my I is equal to 1. My key is equal to also 1. Okay, that is a of 1. Right? Now I am taking j equal to I minus 1. So j becomes 0. So you are comparing j greater than 0, and a of j greater than key is this a of j is greater than key. Then you just swap this. Okay, you just swap this a of j plus 1 equal to a of j, right? A of j plus 1 equal to a of j. In this case, what will happen? Key already has that a of 1, that is 5 is there in key. 5 is already there in the key. So now what we are trying to do? A of j, this 13 is kept here. So array becomes 13, 13, 1, 7, 9, 3. Now j equal to j minus 1. So j with this j did not change. So we are making j as minus 1. Okay, right. Next, we do here a array of j plus 1 equal to key. So what is there in key? 5. that I am putting in j plus 1. So at the 0th location, we made it minus 1, right? Minus 1 plus 1, it becomes 0. So here we are replacing it with 5. I have chosen this element. I have chosen this element. I am comparing with the previous element and repeating this. Again, it will go back. This is done. Again, it will go back here. So j value is minus 1. It will not do this. Again, it will go back. I becomes 2. So this becomes my key now. This element becomes my key. With this, again, I will repeat the same procedure. Okay, I'll repeat this, how insertion sort is working. We try to take, when we have array elements like this with us, we try to take this element as the key. You compare this element with this element, and accordingly you will swap it. Then you will change your index to this location. Then compare this with this location and again with this location. So first this one you will swap it. Again this one you will swap it. This way you keep doing it. So we use this very important statement key. Because why? That's what, that is your new element. Key is your new element. When you are playing cards, on your left hand side it is empty, or there is one card. You are picking your second card from the deck. When you are taking the second card, you will be comparing with the existing card in your hand, so that the card which I am picking is your key here. That I am comparing with the existing array, and then I am accordingly swapping it. Okay, so this is the logic of insertion sort, right? So this is one very important technique, insertion sort. This is again the time complexity remains same. Okay, in this case you tell me, in this case let's discuss the time complexity, the best case, the average case, and worst case. Okay, best case, worst case, and this average case, right? Can you guess what would be the answer? What is the best case for insertion sort? It means in the best case the array given is sorted order. Okay, 1, 2, 3, 4, 5, and 6. It's in sorted order. So what I am doing here, I am taking this element, comparing with this. First iteration fine. Key I am taking as 2. J I am making as 0. Then I am checking this. Is it greater than 0? No, it will not go inside this. Again, it will go here. Right? J value, it did not change. Right? This will fail. J value did not change. So it will repeat this. It will come back. Since it did not happen, it will come back here, go increase I. So I becomes 3, again compare, no, again go increase. So only one time this is happening. So best case, if you see best case, I am just iterating only one time of this array. I am not repeating again here, because this check itself is failing. This check itself is failing. Here itself it is failing. It is not looping back like this. Okay, suppose this here I had 1, I have to loop it back like this. That I am not doing here, because already everything is in order. That's why the best case is n. The best case is order of n. Average case and worst case remain same almost. Why? If it is not in sorted order, you have to always do repeatedly. 2 times you have to do. This will execute n times and this will execute n minus 1 times. So combined together it becomes n square. N into n minus 1. So n square times. So the average case and the worst case is order of n square for this. Okay, because both the case it has to repeat. See, best case cannot be order of 1. Best case can be maximum, or the best can be order of n, because I am iterating over the array elements at least once. Though it is sorted, I have to check right at least once. I have to check right this way. I am doing condition checks. So it is iterating over the array elements. One time iteration over the array elements means one for loop. That is order of n. Okay. So this is about the insertion sort technique.